Let's see how top-down design can help us solve a complicated coding problem. In this example, we are asked to write a program that will fill our canvas with 10 rows and 10 columns of light blue circles. This may seem like an overwhelming challenge, but we can use top-down design to break it into smaller, more manageable parts. The first thing we want to do is break this big problem up into smaller pieces. Our big problem is to draw 10 rows of 10 circles. A smaller problem that will help us solve the larger one is to draw 1 row of 10 circles. And an even smaller problem encased in that problem is to just draw 1 circle. With this in mind, let's write some pseudocode to help us plan our program. The first thing we want to do is have Tracy move to the starting position in the bottom left-hand corner of the screen. Then we want Tracy to draw a circle. In order to draw the whole row of circles, she's going to need to move forward after drawing each circle and then repeat this whole process 10 times. Once she's drawn 1 row, we need her to move back to the top of the next row. In order to fill the whole canvas, we need to repeat this whole process 10 times. Now that we have our pseudocode, we can start writing code to solve each part of the process. The first thing we want to teach Tracy to do is to draw 1 of our light blue circles. Since we know we're going to be repeating this, let's go ahead and make a function called drawCircle. We've already written code that will draw a circle filled in with a specific color, so this isn't a hard problem for us. We'll tell Tracy to draw a light blue circle and then move forward the diameter, which in this case is 40. See, that wasn't a hard problem to solve. Next, we want to take that 1 circle that Tracy drew and draw 10 of them in a row across the width of our canvas. But this won't trick us either because we know how to use loops. We can just initialize our loop before Tracy starts drawing the circle and fill in 10 for the amount of times to repeat. You'll also notice that we changed the name of this function to drawCircleRow because we are now drawing all 10 circles. Another smaller problem we can solve is moving Tracy from her end point after drawing the circles to the top of the next row where she needs to start drawing 10 more circles. We can write a function to solve this problem. Tracy ended 20 pixels past the right side of the canvas after drawing the last circle, because she moved 40 pixels at the end of the loop. She also ended facing right. To get her to the top of the circle row, we need her to turn left so she's facing up and then go forward 40 pixels because that's the diameter of my circle. After she gets to the top, I will have Tracy turn right 90 so she's facing right and then move her backward 400 to get to the left side of the canvas. I've now solved each part of my code, so all I need to do is put the pieces together. I want Tracy to draw a row of circles and then move to the next row 10 times. Let's put this in our code editor and see if it works. I've pasted in the functions that we already wrote, and now we need to move Tracy to the starting position. So let's write pen up and then set position. But what position do we need to set Tracy to so she can start drawing the first row? Well, we know we want her to be right at the bottom of the canvas, so our Y position will be -200. Let's put her right in the bottom left corner to see if she completes our task. Now we need to call our functions, so I'm going to write drawCircleRow and then move up a row. Let's see how this looks. I'm noticing that our circles on the left side are a little off. This is because Tracy starts drawing circles from the bottom center and we lined her up right on the left-hand line. So let's change our x coordinate in our command to be -180. Let's see if that works. Awesome. Now in order to fill the entire canvas, we need Tracy to repeat these tasks 10 times. So let's add in a loop. Right before she draws circles, I can write for I in range 10 and indent my codes beneath. Let's see how that goes. Awesome! Use top-down design to solve the next Tracy challenges.